495.
Yeah, today we're going to look at, on page 495, we're going to look at using slopes, okay, to identify quadrilaterals in the coordinate plane. So now we're going to be using like the coordinate plane, XY coordinates, points and stuff like that. And we're going to identify quadrilaterals based on their properties and using the coordinate plane. Okay, so obviously a lot of the relationships that we talked about, right, so far with these quadrilaterals is that, like, for example, we're talking about parallel, right, sides that are that are parallel. All right, in the coordinate plane, right, we know that two non-vertical lines are parallel if and only if they have the same slope. Right, the same slope number, all right? They have the same slope, that means those two lines will be parallel, okay? So that's going to be key to what we're going to be doing today, is to identify parallel pieces, okay? And we're going to be using this 2 days in a row here, so make sure you don't lose any of these papers, all right? So let's actually skip on here to page 497 and look at explain number 1 up here. Okay. Now, and let's skip letter A for right now. I want to skip down to letter B. We'll come back to A after we do letter B. I want to do B first, because I think we just talked about parallelograms, so it'll be more helpful to go this way. All right, so letter B says we want to show that PQRS is a parallelogram. All right, so what makes a parallelogram a parallelogram? Someone raise your hand and tell me, what makes a parallelogram a parallelogram? So, Ikeva? Okay, the sides must be parallel. Opposite sides must be parallel, right? And so we're going to look here at our shape. So let's, for example, PQ, I want to see if that's going to be parallel to SR. And again, since we're in the coordinate plane, I mean, we can kind of look at it and see, it's like, yeah, it kind of looks like PQ and SR are parallel, but how can we guarantee it? Well, we're going to find the slopes, okay? So we're going to find the slope of PQ. Okay, now, how do you find the slope in the coordinate plane? What's one way we could do this? Rise over run, right? So we can just count if we wanted to, right? To go from P to Q or from Q to P, it doesn't really matter. So let's go from P to Q. And so to get from P to Q, what's the rise that I have to do here, Jaden? And you can look at yours if you need to, or if you want me, I can zoom in some more on mine here. So to get from P to Q, I have to rise how much? I know it's just kind of, sorry?
0.
So I'm not going to go up or down to go from P to Q?
Go down.
Down how much? 2, right? So down 2, that means it's a rise of what number? Very good, yeah, negative 2.
Can't you do 4 over negative 2?
So, no, it's always rise over the run. And so we went down 2, and then we're going to go run, and then we're going to run how much here, Jaden? That's okay.
Is it 3 or 4? I don't know.
It's 4. So again, if you just watch me here, I'll zoom in some so you can kind of see it. Okay. So I start at P. We have a run of down 2, right? So negative 2, and then run. Sorry, that's a rise. A rise of down 2, so negative 2, and then a run of 1, 2, 3, 4.
I would like try to count in the shape.
Okay, just, yeah, try to ignore the lines there and just use, just count over. So, yeah, it's a run of 4. Okay? So now let's find the slope of SR. Okay, so there's the slope of PQ. It was negative 2 over 4. So is it the same thing? Let's see. So Kyle says the same thing. So it's a rise of down 2, so that's a rise of negative 2, over, and then a run of 1, 2, 3, 4. Okay, so are those two slopes the same? They are, right? So that means these two sides are parallel. You can mark that in there. Yes?
Well, I don't understand why you don't do PS and PR.
Right, so great question, right? So what I've done right here, is this enough to say that this shape is a parallelogram? Have we done enough here?
Yeah.
No.
So all I need to show is that one pair of sides are parallel? No. Right, we got to show the other two sides here. So that's why you came. So I was holding off on that. So yep, let's find the slope of PS. Okay, so let's start from P and go to S. So I'm going to go down 1, 2, 3, 4. So that's a rise of negative 4 over, and then down 4, right 2. So over 2. Okay? So let's find the slope of QR. Okay, and again, I'll start at Q. And we're going to rise 1, 2, 3, 4, and run 1, 2. So negative 4 over 2.
So is it always going to be like that, or no?
What do you mean, is it always going to be like that?
Or is it big or no?
Well, great. So in letter B it says show that PQRS is a parallelogram, so it better be this way if we're trying to show it's a parallelogram. Sometimes, Jade, you might be asked, though, show that it is not a parallelogram, in which case you'll want to still do the slopes, but then you'll see that one of the slopes will be, not the same, right? So anyway, now we do know that they're the same, though, we can mark those two sides parallel, okay? And then is this enough to say that this shape is a parallelogram? Both pairs of opposite sides are parallel? Yeah, it's a parallelogram, okay?
Is that all you need?
So I'm just going to say PQ is parallel to SR, comma PS is parallel to QR because they have the same slopes. Okay. So PQRS is a parallelogram. I'm running out of space there. Oh, I'll zoom out just a tad. There you go. Okay? This work is necessary. I know some of you guys don't like having to write more than you need to, but this is good. If you want, we need to be able to explain too. Okay? Should this show up like on the benchmark or something like that, right? We want to be able to like show our work here, and then also give a little sentence just to say why we know this shape is a parallelogram. In this case, it's because the opposite sides are parallel. Okay, and they're parallel because they have the same slopes. So PQRS must be a parallelogram because opposite sides are parallel. Okay? All right, questions on any of that? Pretty straightforward, right? All right, not too bad. And we're just counting the slopes there. All right, let's scoot up then. May I scoot up here? Okay, and let's look at letter A. All right, so now we're asked to show that ABCD is a trapezoid. All right, now what makes a trapezoid a trapezoid? It's a quadrilateral with what?
One equal side. A right angle.
So it could have a right angle in it. It doesn't have to have a right angle in it. One equal side is, they all have one equal side, right? Because they're just one.
There's no equal sides in there.
Yeah, well, I think what he meant, I'm not sure. Okay, so I'm not sure what was going on there. Sorry. All right, I don't know. One equal side is just like one side equal. So it's equal to what though? I guess. So
isn't it like a trapezoid not symmetry?
So this is a non-isosceles trapezoid right here, exactly. But again, what makes a trapezoid a trapezoid? How? So you notice here, it looks like there's how many pairs of parallel sides?
None. I don't know.
It looks like AB is maybe parallel to DC, right? So in a trapezoid, if you remember the definition for a trapezoid has at least one pair of parallel sides. That's the trapezoid. Okay? Trapezoid has at least one pair of parallel sides.
And what makes it isosceles and non-isosceles?
So, well, think about it this way. What makes a triangle isosceles? At least two sides are congruent, right? So in a trapezoid, at least two sides are congruent. In this case, you can see.
I thought isosceles had to be all sides had to be congruent on a triangle.
No, for isosceles that's equilateral, right? Equal sides for equilateral. Isosceles is two or more. So an equilateral triangle is isosceles, but it doesn't. But an isosceles triangle could also just have two sides congruent. Anywho, so there's the shape. So, and Haley correctly pointed out here that it looks like the one pair of parallel sides is AB and DC. How can we show that AB is parallel to DC in the coordinate plane here? What do we need to find? The slope. So let's just count the slope. So we'll do the slope of AB. We'll just count it here. So from A to B, I'm going to go up 1, 2, and right 1, 2, 3. So up 2, that's a rise of positive 2, and right 3 is a run of positive 3.
So, remember how in like the first one we had defined 4 slopes?
Mm-hmm.
So how do you do that? Would you be finding like you already know that AD and BC aren't going to be parallel. So what are we trying to prove?
Right. So what are we trying to prove? Let's go back to the directions. Show that ABCD is a trapezoid. To show that something's a trapezoid, it's sufficient to show that at least one pair of parallel sides. Okay? So all we need to show is one pair here, but not both. So, okay? So now slope of CD, let's count that. So to get from D to C, I'm going to go up 1, 2, 3, 4. So that's a rise of 4 and a run of 1, 2, 3, 4, 5, 6. Okay? So wait a minute though. 2/3 is not the same thing as 4/6, right? They're not equal. They're not the same numbers. Oh, what can we simplify here, Skylar? How can we simplify 4/6?
It'll be 2/3.
Yeah, if you divide the top and the bottom. So if you simplify the 4/6 to 2/3, then you do see that those slopes are in fact equal. 4/6 is the same thing as 2/3. You're welcome. Okay. If you have a graphing calculator, it's easy to simplify fractions in your graphing calculator. You just type in the fraction 4/6, you hit math, and then enter, and it simplifies it to 2/3 for you. Okay. So it's 2/3. And so then, is this shape a trapezoid? Yeah. Since AB is parallel to CD, ABCD is a trapezoid. Okay? It was sufficient to show one pair of parallel sides there. We don't care what AD and BC are. Okay? Alright, that's it. Alright? So we've shown it's a trapezoid. Okay. Is this trapezoid also a parallelogram?
Huh?
Is this trapezoid also a parallelogram? Why not, Ramel?
Because
All the sides aren't equal. So in a parallelogram, all the sides don't have to be equal, but opposite sides have to be equal. And AB certainly does not look the same thing as CD. AD does not look the same thing as BC. Also, you could say parallel, like our opposite sides parallel. Well, AB and DC are parallel, but does AD look parallel to BC, Ramel? Does AD look parallel to BC?
No.
Yeah, no. So definitely not a parallelogram, but it is a trapezoid. Okay? Is a parallelogram a trapezoid? Is this shape a trapezoid?
Yes.
Does it have at least one pair of parallel sides?
Yes.
Yeah, so it's a parallelogram. It's a trapezoid as well, by the definition that we use in the book.
But a trapezoid is parallel.
Not necessarily, right. Okay.
Well, what do you mean not necessarily?
So, like, if you have a trapezoid, so you're...
This specific
Yes, that one that we
trapezoid.
saw was not exactly right. Yes, for sure, no. Okay, so let's take a look at these two here real quick. I'll call on some people to kind of help us out. Okay, so we want to show that JK element is a trapezoid. Sure. All right, so Xander, number 4 here. If we want to show that this shape is a trapezoid, okay, if I want to show that this shape is a trapezoid, I need to show how many sides are parallel. Just 2 sides that are parallel. So what 2 sides that look like are going to be parallel in this shape here, Xander? Yeah, that's great. Exactly right. Very good. Important you can do that, or you can identify that. So slope of ML, and we'll do the slope of JK. Okay? Very good there. Thank you, Xander. So let's go to someone I haven't heard from. Yeah, let's go to, oh man, there's so many people. Who? All right, Dominic. All right, so Dominic, can you help me count here? And you can use your own paper there if you need to. Again, we're on page 498. I think I see you there, though. So, Dominic, what's the slope of ML? What's the rise? To get from M to L, we have to go which direction?
Wait, I don't write here.
So we're going to go right through. So that's our run. Our run is positive 3, and what's our rise? From M to L. Are we going up 1, down 1, what? It's from M to L? Yeah, we went down, 1, down. So that means the number we'll put on top is going to be a negative 1. Okay, good. And then go ahead, Dominic, would you do JK as well, please? Shh. So from J to K, what's our rise? Okay, down 1. Let's see. I don't think that's going to be quite enough. Down 2, yeah. Shh. Okay, down 2, and then what direction now? Right, how much? 6. Very good. Now again, if we look at these two numbers, does it look like they're the same number?
Yes.
Yeah, not quite, right? But what can we do here, Jason?
Can't you divide it
Divide the top and bottom by what number?
by 2?
Yes, very good. And it simplifies then to negative 1/3, and they are in fact the same. Okay? So, Dominic, is this shape then a trapezoid since we have one pair of parallel sides? Yes, it is, yeah. So JKLM is a trapezoid because ML is parallel to JK. Okay? See how nice it is using these symbols rather than have to write the whole word out? You know, ML is parallel to JK. You can just put the little symbols in there. It makes it so much quick. You think so? It's, I understand. It's like more interpretation necessary. Yeah, I got you. Okay. All right. Let's skip down here to number 5, and then we're going to move on to using perpendicular slopes. Okay. Oh, you're good? Okay. Very good. All right. Skylar, ABCD. So if we want to show that ABCD is a parallelogram here, what do I want to do? What can we use? Okay, so we're going to find the slope of AB and CD first. Okay, so let's count those here real quick. So, Skylar, what's the slope of AB? Sorry? 6/4, thank you. And then what's the slope of CD? -6/4. Okay, so folks, you'll see here that Skylar counted the slope A to B. She went up 6 and then right 4 to get to B. Okay? For the slope of CD, she started at C, went down 6, and then left 4, which is right, -6/4. So wait a minute, though. Now we're ending with 6/4 and -6/4. Are these two slopes the same?
Yes, they are.
Why? Wait, but what? One has positive, one's negative, though.
If you do, it's like if you start from D,
Uh-huh.
C, then you still get 6/4.
So, but wait a minute, though. Shouldn't we be able to go either direction and still get the same slope? You're right. If we go from D to C, we will go up 6 and right 4.
If you go from D to A, you'll get -6/4, right?
What's negative divided by a negative?
Positive.
Positive. So it's the same thing as 6/4. This is the same thing because it's negative over -2. But you're right. I mean, Jason, your logic was right too. That's good.
If it was 6/4 and the other one was -6/4, that would not be.
That would not be the same, right?
Okay.
All right. So that's good. So now we'll look at what other two slopes here, Skylar. A, D, and B, C. That's right. Do we have to calculate these slopes too, Jason?
Yes.
Good question. What do you think? If we're trying to show it's a parallelogram,
Yes.
we have to show both pairs of opposite sides are parallel. So yes, yes. Okay. So the slope of AD there, Skylar, is what? -2/1. Perfect. And the slope of BC? 2/1. Okay. So again, Skylar started at A, counted down 2, so rise of -2, run of +1, and then she started at C and went up 2 and then left 1 for a slope of 2/1. Now, are these two slopes the same?
Yes.
So let's see here. I'm going to type this into my calculator. -2 divided by 1 gives me -2. 2 divided by -1 gives me -2. So are these two slopes the same?
Yeah, but you could also make it easy on yourself and do it the other way.
And count the slopes the other direction. So these slopes are in fact the same slope number, okay? -2 divided by 1 is the same thing as 2 divided by -1. Same slope. So they are parallel, okay? So since AB is parallel to CD and AD is parallel to BC, then ABCD is a parallelogram. Yes, sir.
Never mind.
Okay, and you can draw the little symbols there if you want to. All right, so questions on any of that? I feel like we're all getting this pretty good, right? We just found the slopes. That's not too bad, right? We're going to look at now perpendiculars, and that's just going to be like one little extra thing. That's it, okay? So are we good to move on?
Yeah.
Okay. Jordan, here, I'll leave this with you real quick if you want to like finish copying there. All right, so let's move on then to page 509. Okay, we're going to look at this section too. 509. Because we're going to come back to that section later.
Can we do this?
Tomorrow.
Algebra.
You like algebra?
I love algebra.
Good.
Give me a formula and I'll give it to them.
All right, very good. So your next class will be algebra 2, and you should be fine in
I
that
have
class.
algebra.
Oh boy. Who else in this class has algebra 2 next semester? You guys want to raise your hands? Okay, a handful of you. Okay. Ryan's like, I don't know, this geometry stuff. Oh. Gotcha. Okay, thank you. Okay, so quickly now, let's go and talk about perpendicular lines. All right, so be careful, we don't get these two things mixed up, right? Parallel lines, same slope. We have the slope criteria for perpendicular lines. So one way we can identify perpendicular lines is if two non-vertical lines are perpendicular if and only if the product of their slopes is -1. Or what's the other way we have to determine whether lines are perpendicular? What's true about their slopes? They are...
Equal.
No, they're the same. They're opposite and... What does it mean when you flip it? Reciprocal, yeah. Or slopes, I'm going to put that in here, or the slopes are opposite reciprocals. Okay, so as an example here, okay, as a quick example,
What does that say? Or slope?
or slopes are opposite reciprocals. Okay, so as an example, if we have a slope of 3/4, okay, then a perpendicular okay, if we have a slope of 3/4, then a perpendicular slope to that would be what? Over what?
3/4. 4/3.
Perpendicular. Parallel would be 3/4, so it would be 4/3 flipped, and then we make it, since this one was positive, this one will be what?
Negative.
Negative 4/3. Okay, so...
Negative 4/3 could also be -4/-3.
No, sorry, it could be, you could say -4/3 or 4/-3. If you say -4/-3, the negatives cancel and it actually becomes positive
So
4/3.
you can't do -4/+3?
Yes, that's okay. But you can't do, you said -4/-3, the negatives would cancel and give you a positive 4/3, which is not opposite. Okay? Alright, so moving on here real quick, page 511.
Are we in there till 9:10?
I'm sorry?
No, I thought we were in here till 9:10. Yes.
Yes, 9:10. we won't be like doing notes till that long. We only have about like five or so more minutes left of notes, and then I'll give you guys your assignment. So you'll have a lot of time to work on your homework, basically. Okay. So here, Derek. Example 1. Show that each figure is the given type of quadrilateral. So again, page 511. Sorry, page 511. 511. Okay. Now, because we're talking about perpendicular, we can start talking about like rectangles and rhombuses, right? Because those perpendicular stuff shows up in rectangles and rhombuses. Okay, bless you. Okay. So, show that this shape is a rectangle. Now, if you look at it, does it look like it's a rectangle? Yeah, so we're like pretty convinced it's going to be a rectangle here, right? If I take a corner of my paper and like put it in one of the corners there, that looks like it's a right angle, you know, and stuff like that. So, probably. But how can we be sure we're going to use slopes? Okay? And so, we have to check all of our slopes here, okay? So first, let's determine if this shape is a parallelogram. So let's count all of our slopes. We'll do the slope of AB. I'll kind of zoom in over here. Okay.
It looks really difficult when they're doing it.
Ooh.
Is that, what is?
Sorry, I want to do AD. So slope of AB, slope of AD. So we're going to do, oh, wait a minute. Now I'm sorry, folks.
Wouldn't it be AB?
And DC. DC, sorry. I'm so sorry here, folks. There we go. That's right. Okay? So we're going to do the slope of AB, slope of DC. Okay? I want to do the opposite sides there, right? AB, DC. And then we're also going to do the slope of AD and the slope of BC. Okay? And you'll see here, with the same calculations we did before, we're going to be able to show that this shape is not only a parallelogram, but also a rectangle, guaranteed.
And trapezoid.
And trapezoid as well, sure, very good.
That could be a trapezoid?
Yes, because,
I thought trapezoid would have that line.
yeah, so good, kind of question here, right? So let's think about that. What makes a trapezoid a trapezoid? At least one pair of parallel sides. If I show that we only have just one pair of parallel sides, this shape's also a trapezoid, guaranteed, by the definition. Okay, so let's quickly count AB here. So AB slope is up 1, 2, 3, and over 1, 2, 3, 4, 5, 6. Thank you. Okay, DC also has a slope of 3 over 6. Okay, AD has a slope of down 2, right 1, so negative 2 over 1. And then BC has a slope of also down 2 over 1. Okay. So, is this shape a parallelogram?
Yes.
Yes, right, because opposite sides, the slopes are equal, okay? So, AB is parallel to DC, and AD is parallel to BC, because, I'm going to kind of abbreviate here because I'm running out of space, because their slopes are equal. Okay.
So how is that showing that that's a rectangle?
So great question, right? All I've shown here is that ABCD is a parallelogram. Oh, I'm going to run out of space. Ooh. Okay, there we go. It fits, barely. Okay, all we did by doing that then is showing that ABCD is a parallelogram. What else must be true for this thing to be a rectangle? Opposite sides will be guaranteed to be congruent. Right angles. Okay? So, how do we determine if we have a right angle here?
You can tell, you can see it.
You can see it, but how can we tell using the slopes? If AD is perpendicular, well, I just gave it away. If AD meets DC at a right angle, that means these two things are perpendicular, which means their slopes should be what? No, perpendicular slopes are not the same. Opposite reciprocals, that's right. So I got to look here. Does AD have an opposite reciprocal slope to CD? So here's DC, there's AD. So these two middle slopes, are those opposite reciprocals?
Why are you looking at DC and AD?
AD and DC. So we're going to see, is there a right angle right here between these two sides? Haley says these are opposite reciprocals. Haley, I don't know if I see that here. I see negative 2 over 1, I see 3 over 6. How are they opposite reciprocals?
Oh, yeah, I see it.
3 over 6 simplifies to 1. Is that what you're going to say, 2, Ramel?
Yeah.
That's right. And so does this other 3 over 6. And is 1/2 the opposite reciprocal of negative 2 over 1? Yes.
No, because, there's no negative in one and two.
That's what I'm saying. If this is negative 2 over 1, the opposite of negative 2 over 1 is positive.
No, because if you would have 1 over negative 2, and then the opposite reciprocal is negative 2 over 1.
So,
That would be the same.
yeah, so when you when I say the opposite sign. This number, this value here, negative 2 over 1 is a negative value, right? It's negative. And 1 over 2 here is going to be a positive value. So that's why they're opposites. This is a negative, this is a positive number, right? If I put a negative 2 in the bottom here, like you said you wanted to do, right, 1 over negative 2, right, then this number will now be negative. They won't be opposites, they'll be the same sign. They'll both be negative.
Okay, so if you're trying to find, if there's no diagonal, so why are you like...
Well, we could do the diagonals too if you wanted
There's no
to.
diagonal.
We could count them.
How do you count a diagonal?
From A to C, right? So you go up 1, and then right 1, 2, 3, 4, 5, 6, 7. So it went up 1, right 7.
Right.
And then that's like we could find that distance if we wanted to using the distance formula and stuff. And then if you found the distance from D to B, that would also that would be the same distance.
You can take BC and then make sure that the opposite reciprocal is DC.
Yep. Mm-hmm.
And if that's not opposite, then it's not a rectangle.
Right. So because DC and AD are perpendicular, that means this shape is a rectangle then. Okay? Because AD is perpendicular to DC, okay?
I don't have any more room.
I'm sorry. ABCD is a rectangle, okay?
Right on top.
Okay? So there's two things we had to do here. We had to show it was a parallelogram first, then we had to show that it was a rectangle. Again, just using the slopes though.
What is that symbol again?
This one right here
Yeah.
means perpendicular. If you see it, because it kind of creates a little right angle there,
Yeah.
when we put them together. So. Okay, so the rectangle takes a little bit more time. We have to show both that it's a parallelogram and that it's a rectangle. So you show that all the slopes are opposite slopes are congruent, and then also that the consecutive slopes are opposite reciprocals, perpendicular. Okay. All right. Let's look at letter B here real quick, and then we'll stop. Okay. So letter B here. Again, we want to find the slopes. It says here, show that JKLM is a trapezoid with two right angles. Okay? Okay? Where does it look like our two right angles are located? Derek and Jaden. Jaden, I think you should go back to your seat, please. Okay. All right. Where does it look like our two right angles are located in this shape?
Two right angles?
Where are the two right angles? Where does it look like they are located? At which... K and L. Yeah. And so, do I need to find all four slopes here to show that K and L are right angles?
No.
Which slope can I ignore?
KL.
Now I need KL slope.
JM.
I can ignore JM slope because JM does not touch KL at all. But I need JK, I need ML, I need LK. Sorry?
The slope looks like it's on the middle.
It kind of does, but let's count it here. So let's do the slope of JK. Let's do the slope of LK, and let's do the slope of LM. Okay? So let's count these slopes here real quick. So M to L is down 1, right 3, so negative 1 over 3. J to K is down 1, 2, and right 1, 2, 3, 4, 5, 6. And then LK has a slope of up 3, right 1. Yes.
For LK, I got 1 over 3.
Yeah,
Okay, so again, rise is up 1, 2, 3, and then the run 1. So it's 3 over 1. Okay. Okay, so is LK perpendicular to LM?
Yeah.
Yes. How do you know?
So,
Yes. So LK is perpendicular to LM because slopes are opposite reciprocals. Okay.
the right
It-
angles because they're opposite reciprocals.
Yep, the slopes are opposite reciprocals, so we have a right angle there. And then what about JK and LK? Are they opposite reciprocals?
No.
It doesn't look like it,
Oh, yeah, it's big.
but we simplify that, negative 2 over 6 to negative 1 over 3. Are they?
Yes.
Yes. I'm going to put that in front here. So I'm going to say LK is perpendicular to LM and JK is perpendicular to LK. That kind of saves me some room there by writing it that way. So, yes, go ahead. So that's it.
So like, when you're doing this, so...
I'm listening.
Like, why aren't you using JM? It's like, how are you going to compare that?
So JM, if you look here, right, we're supposed to show that JKLM is a trapezoid with two right angles. So I looked here, and to save myself some time, I looked here and I saw that it looks like K and L are the two right angles. JM does not touch those two angles, so I figured it's a waste of time to do the slope of JM. We don't need it. I'm just trying to show that this shape has two right angles, and so K and L are them, and so I just wanted to show that they're perpendicular. That's all. You can do the slope of JM. It's not necessary though, because it doesn't touch one of the angles, so it wouldn't make it right angle. Yeah, I'm sorry.
To find if the angle was 90 degrees, you take... But you could have found JM and ML.
Correct.
And that would have been right?
Well,
JM and ML and that...
you find L, then you're going to be like, you're the slope of this and the slope of this, right?
They would be opposite reciprocal.
They're not going to be because they don't meet at a right angle. They're not. This JM is not perpendicular to LM, so they won't be.
So why are you using JK?
Because JK, it looks like perpendicular to LK, so I wanted to find the slope of JK so I could then show that it is, in fact, perpendicular, opposite reciprocal to LK.
Oh, I get it.
So, but what are you comparing?
The slopes.
You compared LK and LM. So why are you comparing JK?
I did, right here, right here.
How can you compare three fractions?
Well, so we compare them two at a time. I compare this pair to see that I have a right angle here, and then I compare this pair, LK and LM, to show that I have a right angle here.
Okay, why not LM and JK together?
LM and JK, because LM and JK, if I compared their slopes, okay, they would not be opposite reciprocals, because JM and LM are not perpendicular to each other.
I said LM and JK.
LM and JK. You can. So that means they're parallel, which it looks like they are.
The opposite, they're the same.
That's right, because this is a trapezoid, so that's the one pair of parallel sides that we have.
But you said that they all have to be opposite, and they're not.
No. In order for something to be perpendicular, the slopes are opposite reciprocals. So for JK to be perpendicular to KL, which is what we wanted to show, the slopes are opposite reciprocals. We showed that, right? JK, LK, okay? Likewise, we want to show that ML is also perpendicular to KL. And I look at their slopes. Is LM's slope opposite reciprocal to LK's? Yes. So they're also perpendicular.
I don't understand why you're not comparing LM to JK.
LM to JK. I mean, we can, and that gives us the parallel sides. So LM and JK, those sides have the same slopes, that means they're parallel. But that's not what I was asked to find. I was asked to find that it has two right angles. I guess I was technically asked to show that JKLM is a trapezoid, so I should say that then these two, we have one pair of parallel sides. So that's true. Yes, and then Haley gets angle K. Angle K equals angle L. Oh, so angle K equals angle L equals 90 degrees. Yeah, no, I'm sorry. It's this letters. It's the word so. And then Haley, you have a question for me?
Like, for example, in the first problem that we did with the rectangle,
Yes.
if you, instead of finding out the lines are parallel first, then you just found out if each angle is 90 degrees.
Yes.
Like, wouldn't it have to be parallel then?
Yes. So Haley found an alternative here. All right, Derek, Jason, Ryan, Brianna, whoever's listening over there, listen up here, okay? Derek, I need you to stop taking away my attention, okay? Because I can guarantee you guys, whatever Derek's telling you won't be on the Friday's test, won't be on the CREST. Probably can wait until after class to figure it out, whatever it is, okay? So please, you need to listen to this. So Haley pointed out something important here, right? So if we're trying to show something's a rectangle, we can show that it's a parallelogram first, and then just show one right angle. Or like Haley said, we could also show that all four of these angles are right angles, and then that also would guarantee this is a rectangle as well. So yes, you could have done that too. Okay, so there's more than one way to do this, but again, it's mostly using the slopes. You need to find those slopes, okay, to then match up with your properties. All right, any other further questions on that? All right, so see, that's it. All right, so now I'm going to give you guys your assignment. I hope, I'll come around to help too as necessary. So, going back to the old pages that we were talking about, okay, I want you to look at page...
In the other book?
Sorry, no, I mean earlier.
Because you said old.
Yeah, I know what you mean. I'm sorry, I said, I was way too